Hello to all of you. This is the interface of the Staad software. We can see here a new project file option and configurations. We can also see here the recent file. We also use or we also create before. We can see here the geometry of this file, and we want to set first of all configurations. Then click on the configuration option, and this new window is open here. We can select here base unit first of all, then we select the metric because we work in the meter and kilonewtons. That's why we select the metrics unit base. We can also select here to background of the working platform of the Staad software. Here we select the white background. Here we select first code. We can see select code during the process, and then we can also select this code from here. For steel design code, we can use IS 800, IS 800 2007, LS limited designs. For concrete designs, IS 4x6. Okay, then apply and accept it. Okay, go to new project, click on new project. We want to work in 3 dimensions, X, Y, and Z coordinate. That's why we select the space and length unit meter, force unit kilonewton, and we can first of all we give the project name. We select give the project name as analysis of building, design and analysis of building. Now building, okay, and we also give this here storage path to store this file in separate folders for our convenient. Okay, then go to next and finish. This is the working platform of the Staad software. And first of all, we create in the geometry in the this, and then second go to general and design. Give a properties, give a supports, give a load combinations. Okay, so here we can see this is the menu bar. This is the horizontal toolbar. This is the vertical toolbar. Here we can see here is the view from Z. It means we can see a front view. It is the view of from minus Z. It means this is the back view. Okay, this is left hand side view from X minus X. Okay, this is the plus X from left right hand side view. This is the top view. This is the bottom view. This is the isometric view. Okay, and this is the rotations tools for the geometry. We can rotate geometry also using this tool. Okay, and this is the zooming view, zoom in, zoom out. Okay, this is the add beam node. We can add the beam using this node. We can add plates using these nodes. Okay, and this is the selecting arrows. This is the node cursor. It is a beam cursor. We want to select a beam, then use this cursor. We want to select a plate, then use this cursor. Okay, these are the cursor, and these are the we want to edit a support, then use this support edit cursor. Okay, this is all the circle here, and then first we create the geometry. Geometry creates For creating a geometry, many methods like this we can use these grids and create also geometry. Add beam and go to beam, and we can use this. Okay, and then first select the coordinates and copy and paste. We want to this arrow in this direction, then we move in y direction in minus because go to the downward side. That's why we select the minus. 2 meter, 5 meter. Okay, select. Okay, and then go to beam and we add the beam. Okay, these methods first of all, and next method is that coordinates method. We can type here ordinates. First ordinate is always 0 0. Second ordinate, suppose we create a 4 by 4 meter by 4 meter line area for a simple frame. Then we give x direction in 4 meter, give z in 4 meter. The point is created here, the node is created here, and 4 meter in z directions. This third node is created here, and we want to create here next point. Then complete our this rectangular or circle cursor square, sorry, square. Okay, then we type the 4 meter here and 4 meter here. Then this is also created, and then we select the beam and add a beam here. Left click on the node and left click on this node. Beam is created. We want to give a column, then select the circle first, select the geometry and go to transitional repeat, and we want to move in the y directions, then copy link. This option checked for the automatically column is created. Okay, give a distance 5 meter. Okay, and then okay, this frame is created and the bottom beam is delete. In this way we can also create the geometry. Okay, and we go to simplest method to create a geometry. Go to geometry, go run structure wizard, and select the frame models, bay frame, and here we can see give a length. Suppose we select the 12 meter length in 4 segment. We give height. We want to create a G plus 2 story, then 3 meter of each floor, and the 3 floor multiplied by 3 by 3, and here we want to add the length height also. So we will give here length height as 0.5 meter, then total overall height is 9.5 meter. Okay, we want to select here segment is a 4. Number of bays in height means the divisions of that 9.5 meters. Okay, give divisions here. First we select zero point 0.5 and then select 3 meter, 3 meter and 3 meter. Okay, and then width is 12 meter and segment is also 4. Each segment has 3 meter length. Okay, and apply it. This frame is created here. Okay, and then we this frame installed in the working platform. The close, yes. The give the first ordinate 00 ordinates. Okay, then okay, this frame is created here. Okay, so our geometry is created here and finish this geometry sections. Then go to next general tab. Okay, first of all we say give the properties, then select the properties and define. Select rectangular. First of all we give the beam properties. The select beam is 0.230 and depth is 0.450. Then edit and give column size is 0.450. Okay, then add it, close it. First of all we give the properties to this geometry. Select, first of all select the beam properties and go to select beam parallel to in x direction, beam parallel to in z directions. The beam is selected, all beams are selected. Then go to assign to view beam and assign. Properties is given here, r1 to beam. Then next we will give the properties to column. Then select the column name, column properties and select in y direction. All columns selected. Then assign to view, assign to selected beam and assign and okay. Okay, is the properties phase complete. Then go to support phase and create support here, create support, and we want to give a fixed support. Then add it and select support and go to front view because for our convenient. Then go to node cursor and select node and assign to selected node, assign and okay, supported, assign here. Okay, then next we go to load and definitions. We give here seismic load definitions and edit. First of all we select the code type. We use the Indian standard 1893 code. Then select okay, and here give, we select zone 4. Then we'll give the zone value 0.24. Response reduction factor we select from here, from the code. Response reduction factor is select 3. Then give here 3. Importance factors, importance factors we select 1.2 and give 1.2 values here. Rock and soil size as it is, damping ratio as it is, and then go to add and add the self weight. Okay, and close it. And then next we go to load case details and edit. First of all select the dead load, give your name dead load, load and edit. Next we select the live load, live load and edit and close it. And yes, also we edit the seismic load here. Seismic load in x direction, x direction. Okay, and edit seismic load and in z direction. Okay, edit, and also give in x minus x direction and edit and minus z direction, edit and close it. Okay, uh, we give this x directions, go to seismic load, net directions. Okay, factor 1, edit, go to z directions, add and seismic loads, z, select z direction and edit, close, give minus z, add x direction, seismic load and x directions, give minus 1 because in the minus directions we give that, edit and close it and go to z directions, edit, seismic load, give here z directions and minus 1 because in minus z directions. Okay, edit and close it. Okay, give the dead load and edit. First of all we give the sulfate, edit. Okay, and next we go to add a floor load. We select dead load as per our report. Here we select dead load as 3.125 kilonewton, then edit here 3.125 kilonewton in minus directions. Okay, because we this load act in the minus y directions, that's why. And here we give range. Our structure height is 9.5, then give a 10-meter height. Okay, here, and there's a load, the slab is here two-way slab, that's why we not select this one-way distributions. And to edit, next we go to member load and uniform force and give the partition wall load here. So what was the partition load over here? The load is here is partition wall 0.23, 30.8 kilonewton per meter. Then give here minus 30.8 kilonewton. Okay, my direction and add it and give here and edit. We can close it. All load we can add live load, edit and go to floor load, and here selected we live load as 3 kilonewton. That's why here type minus 3 kilonewton and range 0 to 10 meter and edit and close it. And then assign the load, select the sulfate and assign to view, because sulfate is everywhere in the member. Let's select assign to view and assign the sulfate, assign to all beam and column. Then assign a partition wall load. Then select this load and select the beam because we applied the partition wall in the beam. Then go to select X directions and select to Z directions. The select all beam, then give to selected beam and assign. And yes, this partition wall load is applied. Okay, then uh, go to load combinations and define a combination of load here. Here we select here dead load as 1.5 and live load 1 1.5 and edit and close it. Okay, this phase is complete. Load applied and go to analysis as print and go to all and edit and close it. Analyze the structures, go to analyze 5, save and analyze the structure. Go to analyze and here zero error. Go to post processing and done it. Apply. Okay, here we can see reflection. Go to result, value, beam and displacement and annotate here. Close it. You can see here deflection of the frame. This is the deflection of the frame. Okay, we can scale it, zoom it. This is the deflection. We want to select the reactions, then it will give all reactions here. Okay, beam, shear force and bending moment diagram, the frame. Go to results and values. You want to beams, you want to ends behavior bending, then click ends, noted, close it. This is the end. Reactions. Want to see here select results, scales and shear end, then okay, noted. Here the beam is option is and shear beam. Okay, we can also use this toolbar and scene. Okay, we want to see annotations, then deflections and go to apply and okay, we can see here this frame is hanging. It's the deflections. Okay, create this all these things and go to modeling and then go to designs, go to concrete design here and select parameters. First of all, select the basic parameter for the concrete FC compressive strength, then select the Fi stress of the main steel and the Fi secondary steel field stress and OK and close it and define parameters. We give here use the M20 concrete, then 20. Okay, edit Fi. We here is F500, then edit F500, edit, close it and command. We design a beam, add, design column, add, design, close it. First of all, we give assign this F20 to whole view and assign to select view and assign FE charge assign to view, select geometry and assign to Mhm. Design a beam. Go to select parallel and x directions and go to select z directions to select the beam and assign to view and beam and assign. The in this way the beam assign as per the our IS code according to beam design. Okay, select a column and here in y directions and select a column and okay, applied it. Then go to analyze, save it. Here we can design the concrete. Okay, the deflection value is 0, then it suggests our design is safe. Okay, and this phase is completed. Then go to foundation design and select all these loads and include all and go to runs Staad Pro foundations. This is a separate folder, separate software, and go to this software. Okay, click here and open the new software here. This is our foundations footing design here. First of all, we select here generate load combination, generate load combinations here automatically. Okay, okay, and close it. Next, to set up the job setup, create job here and give the project name, design and analysis, and analysis of building. Okay, and select we want to select create a isolated footing. There's select here isolated. Here select India and assign to all supports. Okay, and then give all the load cases and create job. Go to isolated footing job and design parameters and geometry, footing geometry. Here we want to select footing type, then select here footing type. We want to select create a slope footing, then click on the slope. Okay, and then soil. Here we give the soil properties and we want to change it, then change sliding overturning. This gives the criteria over here, concrete and rubbers. Okay, and go to design and okay. Here designing the footings for the buildings, foundations, process is running here. It will take a few minutes, wait for the result. Here the design is completed. It's okay. And this is our design. If you want to see the design of footing 1, then click on this footing 1 and design is here. Okay, this is the file, and we want to do geometry, then this is the geometry. Detailing schedule, this is detailing schedule of this foundation footing. Here we can see detailing foundation size, and okay, here we can see all the footings. This is a calculation sheet, and in this way we can design the footing. Here we can see the dead load, self weight of this, and the partition wall. Here we can see live load on the floor. Okay, here we can see dead load on the floor. Here we can see the partition one load on this beam. Okay, in this way we design a multi-story building in a few hours. It will help you to reducing the time for design, and is very benefit to civil engineers. Thank you.